Well, this problem involves solving initial value problem composed by a differential equation and a condition. So notice that the equation is of the form a 1x dy dx plus a sub 0 of x y equals f of x. So if we divide everything by a sub 1 of x, then our equation will be dy dx plus a sub 0 of x divided by a sub 1 of x times y equals to f of x over a1 of x. And then we can call p of x as a sub 0 divided by a sub 1. And then we can call q of x as f of x a sub 1 of x. And then this is a linear equation of the form dy dx plus p of x times y equals to q of x. Notice that p of x and q of x are functions depending on x, and then y in the middle term is on the left is raised to the first power. So we can do or follow this procedure to our given equation and then divide the given equation everything by sine of x. So we divide everything by sine of x. So our new equation will be dy dx minus cosine of x over sine of x times y equals to e to the x sine square of x over sine of x. And then we know that we can write it as dy dx minus cotangent of x times y equals to e to the x times sine of x. So this is a linear equation. It's a linear differential equation, right? So this form is the same as in this general form. So we can identify that p of x is negative cotangent of x, and then q of x is e to the x sine of x. Right now we can now compute the integrating factor for this linear equation. We call the integrating factor. It is time to find out the integrating factor, which is u of x is e to the integral of p of x dx, which in this case it is e to the integral of negative cotangent of x dx. So we can put the negative outside the integral, and then we have the integral of cotangent of x, which is cosine of x over sine of x dx. And then this integral can be solved using substitution. We can say that u is sine of x, then du will be cosine of x dx. So our integral now, to find the integrating factor, we have e to negative du over u, because sine of x is u, and then cosine of x is cosine of x, and d of x, cosine of x dx is actually the du. And then we obtain that the integral is e to the integral of du over u is ln absolute value of u. Then let's assume u is positive, and then we can rewrite it as e to ln of u to negative 1. Then we have simply the exponential and the log cancel each other, so we have 1 over u. So replacing back u as sine of x, we have the integrated factor is 1 over sine of x. 1 over sine of x. So it is moment now to multiply, and then what we call 1 over sine of x is equivalent to cosecant of x. So now the next step is to multiply our linear equation by the integrating factor. So our linear equation is the one in blue, and I'm going to rewrite again dy dx minus cotangent of x y equals e to dx sine of x, and is this equation the one we're going to multiply by cosecant of x. And remember, cosecant is 1 over sine. So what we're going to have, once we do that, we have cosecant of x dy dx minus cosecant of x cotangent of x times y equals to simply to the x, because sine of x times cosecant of x, they cancel each other. And then we can write the left side of this equation as, remember, since it is linear, it's going to be the left side is the application of the product rule of some multiplication. So notice that we have cosecant of x dy dx minus cosecant of x cotangent of x y. So if you notice that the derivative of cosecant of x is negative cosecant of x cotangent of x, then we can rewrite the left side of the equation as cosecant of x times y. And then the right side is e to the x. So now, in order to find the solution, the explicit solution, y as a function of x, we can move to integration on both sides. So we have cosecant of x times y equals to e to the x plus c. And then we can divide everything by cosecant of x in order to isolate y. We have y equals to cosecant of x, or better, 1 over cosecant of x e to the x plus c. And remember, cosecant is 1 over sine of x. So 1 over cosecant of x is going to be simply, it's going to be sine of x times e to the x plus c. So what left is to find the value of c. So to find the value of c, we can replace the given condition, which is y at pi over 3, y at pi over 3 is equal to -2, the square root of 3 is the condition. Y at pi over 3 is equal to -2 square root of 3 e to pi over 3. So -2 square root of 3 e to pi over 3. So we replace this condition in the explicit solution. We have that -2 square root of 3 e to pi over 3 is equal to sine of pi over 3. And then remember, sine of pi over 3 is square root of 3 over 2 e to pi over 3 plus c. Pi over 3 cancel pi over 3. So we multiply everything by 2. We have -4 e to pi over 3 equals to e to pi over 3 plus c. So we see that c is equal to -5. We can isolate and solve for pi. So c is equal to -5 pi, -5 e to pi over 3. So our solution is going to be, the solution of this initial value problem is y equals sine of x times e to the x minus 5 e to pi over 3. And this completes the solution of the initial value problem.